Well, good evening to you all. I'm going to talk about refrigeration into the future, and I pitched it at a level for those that know something about refrigeration and also those that know perhaps a little less about refrigeration. So it's pitched quite general. So the content of my presentation is why we're important as an industry, why we provide a vital role for society, how we contribute to the economy, how we contribute to the environment, and to look ahead to how we will be in maybe 2020, or what we should be in 2020. I want to start with why we are vital to society. And I've got here a bit of a mosaic of images I've captured from the internet. And these are applications that contribute so much to our lives. And we start off in the left-hand corner with the pear. And that symbolises food manufacturing and storage and drink manufacturing and storage. And refrigeration is a critical part. And without refrigeration, our lives would be so different in terms of food. And then we've got the domestic fridge, and then we've got manufacturing in the UK, a whole range of chemical and drug manufacturing and other manufacturing is so reliant on refrigeration. And then we've got an operating theatre, and then we've got a baby that's been operated on, that's having their brain cooled, okay, to keep them alive while they're being operated. And then we've got the typhoon, and the typhoon is able to survive under combat because of cooling. Without it, it would be gone very, very quickly. And then we've got space exploration, and the one after that is a data centre. And data centres work because they're cool. Without being cold, refrigeration, they wouldn't work. And then we've got maybe some leisure facilities, and then we've got someone that's got a bit of a problem. Because they've been in an environment that isn't cooled properly. And then we've got artifacts that require cooling and conditioning. And the last one is probably the biggest and most important one for us as an industry moving forward, and that is heat pumps, refrigeration for heating. So that's what we do today, and actually we're not standing still. There's other things that are going on as well in the future, and we will expand, we will increase what we do. And this is a list of some of the things that I think we're going to grow into. And down the right-hand side are some diagrams. But let's go through some of these. But local manufacturing is a critical part of government policy on rebalancing the economy, away from service and the finance sector to more localised manufacturing. And that must impact on us as an industry. There's going to be new chemicals and drugs that are need cooling. Domestic cooling. Does anyone know what the green and grey thing is in the middle there? Anyone know what that's called? It's a food store. It's called Shopbox. Okay, and you can buy that from every single retailer. And I think these things are, well, they're coming. It's a way of providing cooling for your food whilst they distribute it at your home or you're out. Okay, and you can rent these for lessen the cost of the delivery. Then the picture next to that is someone under some ice, just about to be operated on. Okay, and it helps the operation process, the recovery process, actually cooling the person down. Defence. The soldier there has got a cooling vest on, and it means that they can, in the fields, they can survive for much longer. Okay, in hot climates. Other things that are going to happen are growth in electronic cooling. This diagram here, does anybody know what this is? Cooling of wires. Why would we want to cool wires? Anyone any idea? Superconductivity. Okay, if we make certain materials cold enough, okay, they can become superconductive electrically. There aren't any losses. Okay, and this is a superconductive cable, and it's got nitrogen in there to about minus 100 degrees C. Okay, this is happening. What else we've got? Growth in data centres, continuous growth is going to be.
internet shopping, more demand for air conditioning, and, as I've said, massive expansion of heat pumps. So we're not standing still. Now, whilst I was looking, I thought they were on the internet for applications. I found some interesting ones as well, which you may want to, I thought I'd share with you. This is a patio air conditioner for the barbecue. That's someone's portable ice bar. Tent air conditioner. This one's a good one. This is a cold sheet for sleeping on. A cold jacket. And my favourite one is a dog cooler. Seriously, we are important because we contribute to the economy. We contribute massively to the economy. Directly, 2.4 billion, 1 in 1,000 jobs, manufacturing plus service maintenance, etc. Indirectly, even bigger. We underpin many sectors. 70% of foods are chilled or frozen, and refrigeration is really important in preventing waste. And we've all seen the cost of our shopping go up. Waste and minimising waste is going to be really important for us in the future. The economy is important, but there are two challenges ahead that I'd like to highlight. Firstly, population growth and resource availability, and secondly, climate change. Population growth. I don't know if anyone's seen these sorts of diagrams before, but these show projections in population. From today, we've got 7 billion. Okay, we've got 3 different scenarios. One, this continuous growth, this median condition, and we all kill ourselves. Based upon the median predictions, we're predicted to grow from 7 billion in 2011 to 9 billion in 2050. But the most important point about that is the actual change in the demographics will be really important. So out of that, currently 3 billion of the developing world will become developed. Okay, so they will become consumers, and as a result they will consume more materials, commodities, energy, water, buildings, etc. So the tension on materials and demand on materials will increase massively over the next 50 years, and we will see that. That's historical commodity prices, and you can see that we've had up until 2000 we've had a reduction, but in 2000 it's gone mad, and the predictions are that it will continue to go mad, and costs up by 1/3 by 2020. Okay, so materials will continue to get more expensive. How will we respond? Less waste, more recycling, reuse and remanufacturing. Those are not my words, those are government words. Okay, and there is a government policy document that was produced in December called Reducing and Managing Waste, and this talks about a zero waste economy. Okay, so it's coming. To help with that, something we should consider is leasing of equipment, because that allows remanufacturing, reuse, etc. And there's a nice little case study about washing machines in the paper. You can look at it later. Climate change, that's my other challenge for the future. And these diagrams I've presented to some of you before, and I apologise for that, but these show temperatures that are potentially going to happen, predicted to happen in 2080, under the low emission scenario on the left and the high emission scenario on the right. So potentially climate's going to change from between 2 degrees C or to 5 degrees C in London over the next 50, 60, 70 years. We've seen weather extreme conditions, and I did a good Google search the last few days, and I found over the last decade or so we've seen changes or extremes in temperature, records being set, high temperatures and low temperatures as well, And in the States at the moment, I've taken this picture from the internet. This is one of the seas or the rivers, okay, that's frozen. It's abnormal in the States. And we've seen in the last few days, haven't we, last few weeks, wet weather as well. So it's not just about temperature, it's about precipitation as well. And this slide shows the potential change in rain under high emissions from 20 to 2080. This is winter and summer, and you can see in winter we're looking at increased rainfall, summer we're looking at less rainfall. So flood, drought, flood, drought. Predictions, are they true? I don't know. But we've seen that, haven't we, relatively regularly last few weeks. And this is actually the Environment Agency floodplain. And we're about there. So from Miriam upwards, you're okay when it starts raining in about an hour. Some people say it's a one-off, okay, and I evidence against that, okay. If you look at the Thames barrier closings, this was a flood defence to help protect us help protect London. It was constructed in '83, and it was suggested it would close once a year, okay. And these are the closings that are reported on Wiki anyway. And you can see 2003 there was 19 closings. Do you know how many closings there's been in 2014? It's 11. Is that right? Or is it more?
No, it's 11 yesterday.
11 yesterday.
We're going to 14 consecutive.
14 consecutive in the first few weeks of January. So that's evidence to show that there is something going on. Well, some people put it down to greenhouse gas emissions, global warming, and the gases that are responsible for that, we're told that 6 greenhouse gases include carbon dioxide and HFCs, hydrofluorocarbons, which we currently use in refrigeration. So refrigeration is responsible for these gases. Refrigeration and air conditioning produces twice the amount of greenhouse gas emissions than air transport. Twice. To be precise, we produce 10% of all greenhouse gas emissions. 16% of all UK electricity. How do we produce that? We produce that in 2 ways. We use electricity and then we emit CO2 at a power station, but we also leak, or we can leak refrigerant, and these refrigerants are potentially greenhouse gases. The proportion between the two, 3/4 is due to energy and 1/4 due to leakage. So we're a big emitter, and therefore we have a big responsibility to reduce our emissions. And UK government signed up to the Climate Change Act, which said we would reduce our carbon footprint by 80% by 2050. And to do that, we have a responsibility as a refrigeration industry. And we are doing that directly through reduced leakage and phase down of high global warming gases. But the indirect is the biggest amount, and that's the one we have to address. Indirectly, we can reduce our emissions through 3 ways. Reduced need for cooling, increased efficiency, and using low carbon electricity. And as an academic, I like an equation. And my equation says that an 80% reduction can be achieved by using a product of 0.6, 0.6 and 0.6 to give me 0.216. Therefore, if I reduce this to 60%, I increase this by 40%, reduce this by 40%, okay, I can get to a 20%, okay, by just working all these three things together. That's really important, okay? Really important to work on those three things together. So how would I reduce the need for cooling? Well, if I had a building or this is a cold store, I would close the door, okay? We close the door, let the cold stay in. Or we would make sure that the insulation is appropriate thickness, and we make sure it works. This is a thermography picture showing a cold store, showing that some cold bridging. Or we would keep the sun out with some shading. Or we would make sure that we used low energy internal lighting to reduce the load in the first place. And the final thing we would do is we would buy the best piece of equipment we can in the first instance. So for instance, supermarket display cabinet. We'd see these, there's thousands of these in the country, okay? This here is a bit of a busy slide, but it shows the energy consumption and this display area for a number of different refrigerators, display cabinets. Ones I'm interested in, these green triangles. And then I'm specifically interested in these two here. And this is Judith Evans' work, by the way. Judith is back there. But you can see this one here has got a total energy consumption of nearly 60 kilowatt hours per 24 hours, whereas this one here is probably about 6. Okay, so if I choose this one, my demand is 10 times that of this one. But they do exactly the same thing. Which one does the customer buy? The cheapest. And which one is the cheapest? The top one. Okay, so it's really important we buy the right piece of kit to start with. We also need to look at how we can improve coefficient of performance, and we can do that by considering the temperature lift between the condensing temperatures and the evaporation temperatures. And this is in our gift as designers. Okay, we can vary these. This is a slide showing the difference between COP and temperature lift, and some of the more traditional books that we use give optimum values. Okay, and this is an optimum value from one particular book. But actually, these values were determined 15, 20 years ago when energy prices were different to what they are today. And actually, we could probably move up to there and have a much higher COP. Okay, it may cost us a bit more money, but we can achieve much higher COP. So we need to revisit these norms. And the evidence to show that we have the capability to do that is this slide here, which compares the COP of some air conditioners that were found in the UK compared to the similar products in Japan. It's not actually COP, it's EER, but you can see here, these are the UK ones. Okay, the COP is much lower than the Japanese versions. Okay, so it's achievable. We can also increase COP through integration, and this is an area which we really need to work on. Integrated heating and cooling. This is a diagram showing the components of a refrigeration system, evaporator, compressor, condenser, expansion device, and it shows some typical heat and energies that are going in. COP in cooling load is the cooling capacity 4 divided by the compressor input 1. So it's 4. In heating mode, 5 divided by 1. In cooling and heating mode, we can get 9. And we need to try and work on how we can achieve those sorts of COPs. Maybe sharing heat with someone else while we use the cooling. And what we must do, and this is a no-brainer, okay, we must insist that our chiller manufacturers install these superheaters on our hot water, okay, so that we have hot waters produced at the same time we have cooling. And this is the superheater, it's in the paper. Heat pumps are really important for the future. And this slide here shows the carbon kilograms of CO2 produced per 100 kilowatt hours of heat for a boiler, and a heat pump based upon today's efficiency and carbon factor from the grid. In the future, as we use more nuclear and more renewables, the carbon factor of the grid will go down. So in the future, this is the carbon that's going to be produced. And if you go to 2035, potentially, we've got a fifth of the carbon or less for conventional boilers. So refrigeration can effectively minimise the carbon that's produced from heating. And the final thing that I wanted to talk about in terms of improving our efficiency was to use low carbon electricity. So it's picking up on the same thing, and these are the carbon factors that are potentially going to happen in the future. We're currently here, 2012, we've got carbon factors for electricity of 0.5, but it's going to drop and drop and drop until it's 0.05, something like that. Why do we think that's going to happen? Because that's what's in our legislation. That's what the Climate Change Act says, 80% reduction of carbon by 2050, and the Energy Bill says we're going to achieve that by decarbonising our electricity grid. So we're going to achieve that through low carbon technologies, nuclear power. Is this a good way of working? Well, DEC seem to think it is, and they've produced lots and lots of models, and they've actually modelled cooling until 2050, and they think actually cooling demand is best just keeping it as it is. So this is cooling here, keeping the demand constant, and achieving our reduction through nuclear and renewables. I don't agree with that. I think we should be doing something different, because I think this policy is too focused on renewables and nuclear. And if you look at renewables, the cost of renewables, PV, as we see on many homes, is expensive, £800 per tonne CO2, whereas the cost of abatement of energy efficiency in refrigeration is much less. So the government should be investing money, more money, in energy efficiency schemes rather than PV that publicly is very obvious. But if they invested the same amount of money into energy efficiency in refrigeration, it would have much bigger impact. Looking forward, without any significant incentives, how are we going to change, and how are we going to move forward? And I've highlighted two enablers. The first one is money. Money makes things happen. Okay, and if we can tune in money with reducing carbon emissions, we can deliver carbon emissions. And this was a subject of David Bostock's presentation recently to the IOR. If we aim at reducing money at the same time as reducing our environmental impact, we can do the right thing for the wrong reasons. Okay, so that's one enabler we should look at. And the second thing is best practice engineering. Okay, there's lots of good stuff that we do, but we need to do more of it. And again, this was highlighted at a recent conference by Brian Churchill of ASDA. And I want to give a couple of examples of where I think money and best practice will be so important for us as an industry moving forward. The first one is how we purchase refrigeration equipment. How do we purchase? What do we use as the main criteria for deciding about a purchase of refrigeration equipment? The cheapest. That's right. We purchase often on capital costs at the expense of energy. And as we've seen with Judith's graph earlier on, we can buy exactly the same piece of kit, one that uses 8 times more energy than the other. Which one do we buy? We buy the cheapest. However, if you look at the life cycle, the cost of the over the life cycle is not dominated by the equipment installation or the service and maintenance. It's dominated by energy. And therefore, if we do a life cycle calculation, it's much better than making an objective choice. Much better getting the best system. So life cycle techniques are really important. And if you look at this guide, it's got some really good life cycle techniques within it. New technologies. Again, there's lots of new technologies that are coming on. There's the refrigeration roadmap, and it's produced by the BRA and the IOR in collaboration with the Carbon Trust. And one of the critical things about it is it shows how much carbon you can save and also how much money things cost. Okay? Cost of failure, reliability is really important. And this is some work that which we've been doing with the IOR over a number of years, but looking at refrigerant leakage. What happens if you get a leak in this case, a supermarket? Well, typically, Christina's here, she found that by looking at 1,500 supermarket records, if you get a leak in a supermarket of refrigerant, you lose 20 kilograms of R404A in this instance. That has a cost, £300. There's also a cost of repair, £500. There's also a stock loss. And my colleague Akosh, I asked him one day to go to Tesco's in Brixton and can you go to the Tesco cabinet and work out how much food is in the cabinet? And he did it. He came back the next day. He said this cabinet on the bottom has got £4,000 worth of food in it, and the one above's got £2,000 worth of food in it. It's right now. Yeah. And if the refrigeration system goes down, you lose £2,000 worth of food, and the cost of the carbon as well, and you lose £4,000 for one leak. So put it into monetary terms, it has a much bigger impact. However, if you put it into carbon terms as well, 20 kilograms of R404A is equivalent to 80,000 tonnes of CO2. That's something like 20 times what I would produce at home, my family would produce. So 20 families for one leak per year. 20,000, sorry. Same as my family for a whole year. Okay, so 20 families for a year is the same as one leak. Okay, it's massive. And the final thing I wanted to highlight in terms of economic best practice is maintenance, proactive maintenance and partnerships. And this shows, Brian Churchard and John Bonner's not here, but this shows the work that they've been doing together with ASDA over the last 10 years. And they've got their refrigerant leakage down by from 54 to 7%. And at the same time, they've saved money. So because their service engineers are now covering more stores and the cost of leakage has gone down. Okay, so it's a win-win situation, proactive maintenance and partnerships. And this is what they've done. This is ASDA, I think. This is their leakage rate. And again, this is a figure from Christina's work based upon some data that she had. She looked at which stores were the ones that were leaking the most. And she targeted. It's not difficult, and able to target the ones that are leaking the most. Good engineering practice. Okay, so the last part of my talk, I wanted to talk about resourcing our profession. And when I thought about resourcing our profession, I wanted to think about what our profession might look like, what a cooling industry might look like in 2020. And I couldn't find a picture of what our cooling industry might look like in 2020. So I found one that it shouldn't look like. Okay, and this shows me everything about what we shouldn't do in cooling. Okay, random. Okay, ill-considered, badly installed, unable to service and maintenance, all of those things. And actually what we should be doing is these things. We should be minimizing cooling. We should be working with new refrigerants. We should be ensuring that our systems have high efficiency in delivering cooling and heating together. We should make sure that our cooling systems and our heating systems integrate with renewable technology. We should share our heat with our neighbours. Dynamic control, we should store. Proactive maintenance, we should recycle, remanufacture and reuse. And that's what I think our industry should head towards if we're going to meet our obligations in the future. How are we going to do this? Well, I put down a list of things that I thought were important for us as an industry. And ultimately, we need to have good fundamentals. We also need to recognise, acknowledge that actually we're a really important industry for society, and we need to tell the world we're important. Okay? We're not metal bashers. Okay? We're a really important industry that perform a fantastic service for society, and we need to tell the world that. We need to make use of the best IT, and to these young guys at the back, okay? My daughter does all these things with the mobile phones and whatever, and there's fantastic things that you can do with these things these days, and you need to try and bring that into our industry, okay? Because it's got massive opportunity. We need to be able to communicate effectively with customers and end users. So if they decide they want to do something silly, you need to be able to tell them, actually, are you aware if you do that, it's going to cost you this amount of money per year? It's silly, you know, those sorts of things. And to work closely with other trades and professions, integration, but we also need to be able to adapt and learn new skills as they evolve. Recently, this guy, Doug Richards, Lord Richards, produced an apprenticeships report. And what he said was industry need to take greater ownership of both standards and delivery of education. And I'm pleased to say that the IOR is reinstating its education and training committee, and with the aim of working with industry to do this. Okay, so that we're delivering the right skills for the future. So looking forward, we need to also be aware of what we've currently got. Our sector is not very diverse. 23,000, mostly white male, less than 1% female. Small businesses, very few ethnic minorities. And we've got a lot of old people. And this is the closest I could get to the demographic distribution of our industry. This is MIMechE, Institute of Mechanical Engineers. And I looked at 1988 data, 2003 data, and 2010 data. And basically, all you can see is this sort of moving each time. Okay, the peak moves like the number of years. Yeah, so from 1988 to 2013, the peak moves 13 years. Yeah, from 2003 to 2010, the peak moves 7 years. Okay, so we've got this this movement of demographics all the way out. Okay, and we need to replace that and grow, and that's why you guys at the back, okay, are so important. How do we attract young people? Well, I put down here the reasons. Money. Okay, and there must be with demand, if demand continues, there must be fantastic salaries, long-term salaries. Global warming is not going to go away. There's going to be variety, because every application is different. When I was an apprentice, working with Tony, one moment we were somewhere, next moment we were somewhere else.
You're there now, and I'm here.
And it's a fantastic world opportunity, and we have the opportunity to save the world. Okay, that's a bit cheesy, but it's true, to make a difference. However, we're not the only industry that's trying to grab these young people. Okay, there's other science, engineering, technology industries are trying to grab, and by 2020, 1.2 million
new people need to come into science, engineering and technology. Okay, and that's 100,000 a year and 60,000 apprentices.
Why would they want to come into refrigeration? And actually, if you speak to them, and this is some work which was done by Nottingham Trent University and Sam Newman at WR just before. She did some work looking at why engineering science graduates could come into our industry, and she surveyed a number of them, and only a few have ever considered coming into our industry. We're not very well known, we're not very glamorous, we haven't got adequate information, okay? Not very many perceptions of our industry. Perceived careers that are glamorous are these. And actually, Sam also looked at their workforce at WR and why individuals ended up in their industry. And if you take out being two-peed in, okay, most individuals in that company ended up in the industry because they're friends and family. Okay? And to be fair, I'm standing here today because of this man. Okay? Leonard Barley. Okay? And Leonard Barley came here, Borough Polytechnic Institute. Okay? And he was here in 1932. He was my granddad. Okay? And he was chief engineer for the coal. Okay? So the reason I ended up in refrigeration was because of him. But actually, I think we can do better than that. We can make sure that we extend our tentacles to make sure that we tell not just our friends and family, all backgrounds, and we extend where we communicate to that there is a fantastic opportunity here. I'm nearly finished. So what can we do? Well, at the IOR, we've been trying to do a number of things, okay? But we need your support. Okay, those members that are active, we need your support to get involved in a number of range of things. We have some material available, the Careers in Cooling video, which I'll play in a bit, and there's some PowerPoint presentations, and we run some Young Engineers Network. But we need to be able to communicate to young people that it's a fantastic career. And it's not just going to be one person that does it, it has to be an army. This one here is an interesting one, and this is my old school, Women's Grammar. And just as you go into the entrance of Women's Grammar, they've actually got these companies now sponsoring. These are huge, great banners. These are 8-foot banners. Okay, this is Caterham Cars, which is made in Dartford. Okay, they sponsor the school. And this one is a company called White Code Design Associates. And White Code is run by Alex Hill, who also went to Women's Grammar, but he also came here. And he's got a massive, great poster at Wilmington Grammar School. How good is that? So it can be done. There can be better interaction. I don't know how long I've taken, but to conclude, I wanted to say that we're a really important industry today, and we're a really, really, really important industry for tomorrow. Okay? We need to grow, we need to renew, we need to adapt. And to do that, we need skills and new blood to come into our industry. And it's not just an IOR thing, it's an industry thing. We can provide some leadership, but we need some support from you. So that's what I've got to say. And these are some acknowledgements of all the people that I've worked with over the years. And Joanne Hall gave me a fantastic opportunity as an apprentice and a whole range of things.